Today, today I'm hoping to have a very short and insightful session so that we can have room for questions and interacting with you. So I'm very quickly going to share my screen here so that we can start. Okay. So anyone, please confirm that you are able to see my screen. Then that will give me green light to go on.
We can see your screen.
Oh, wow. Wonderful. Thank you. Thank you. So let me start by appreciating Sasmo, MULISA, and Maseno at large for another opportunity to come and share with you guys. It's been an honor sharing knowledge with you. So today's session, as I've mentioned, I'm hoping that it's going to be brief yet impactful so that we can have interaction with you guys. And I know we laid a good foundation last week. At least we have not so concrete, but we can call it a rough understanding of what spatial analysis entails. And I know through the week, maybe you have had your own interaction with the video that Mawala and MULISA team shared. Then that goes without saying that you might be having questions, areas of clarification, or areas of interaction. Then we'll have that after 10 minutes or so. So I'm hoping to have an interactive session. So feel free to ask any questions that you might be having, any point that you don't understand. I'm just open, so you can just jump in and ask anything. Now, I'm going to take you through a quick journey of what we covered in our last session, then so that we can have a good flow to where we stopped in our last session. So we were talking about spatial analysis. We were just having a light introduction of what we mean by spatial analysis. So in our previous session, we agreed that spatial analysis simply entails any analysis that has to do with location. Basically, it's just having smart analysis when you are working with location data. So we spoke of that if you have any data that is referring either directly or indirect to a location, this can be the basic geometry of a location that is usually lat long, or it can be an area which is in most cases represented by a string of location coordinates. Like for instance, if you want to define an area on a map, so what you get that a computer can understand is just series of numbers that if represented on a map, and a map is just like a Cartesian plane, a 2D map, just like a Cartesian plane where you have the X and the Y axis. Then if you plot now your point around, then you can have a clear representation of an area. So we agreed that if you have any data that is referring to a location, it can be a point location or it can be an area location, then that data is ripe for spatial analysis. So spatial analysis is just a way to take you a little step back. So it's just a way of analyzing patterns, getting human behaviors, then relating spatial components in a data with other non-spatial component within your data. So we defined terms like GIS and geographical information system, and we said, so don't get confused between spatial analysis and GIS. So we said GIS, geographical information system, these are basically softwares that help you to handle, they help you to analyze, they help you correct, they help you store, and they just help you retrieve spatial data. So spatial data, you can have it in your machine, either in different file formats. You can have it in shape files format. Then, so the GIS, these softwares, they help you retrieve this data, ingest it in your system so that you can manipulate it, do analysis around it, and relate it with other non-spatial data. So I spoke of these three common softwares that I don't know, maybe you can tell me later if you've had a chance to research further on what these softwares do. So if you get chance, I still insist, go through some of these software, especially you can start with the QGIS, as other like calling it. So it's basically an open source software, so meaning that it's free to use. You can download it and start playing around with the spatial data. Then this is where we were winding up when we were looking at the types of spatial data, and we said spatial data can come in three categories. So we can have it as an events data, we can have it as fixed location data, or we can have it as exhaustive data. And we said this data specifically comes in brackets of three. It can be either a raster data, or it can be a vector data or image data. So we said this spatial data, that is vector, raster, or image data, you can have it now in these three main buckets. So where we said it can either be event data, this is very common for spatial analysis. And this is, I usually term this as the most interesting side of the analysis, though the others are very interesting too. When you are talking about event data, it's when you are looking at what has happened where, what has happened at what location. So if you have a series of events, so we were having examples of events like a crime has happened in an area, or somebody has entered a certain location, could be a school, could be a hospital, or could be a secured area. Then you are monitoring the movement within that area, outside that area. So you have series of events. Something is happening within a location. So if you have analysis around that, in the business world, this could be a customer that has purchased at a certain location, and now you are relating the customer purchasing in a location, maybe with the current business model that your company or organization is running in. So these are types of event data. They are very, very common in spatial analysis. Another one we talked of is the fixed location data. And this one we said, this is where you have a fixed location, a well-known location of an object of study. It can be a location or an area, and this location is not bound to change. So within a long time, this location is going to be permanently there. So when you have this type of data, we term it as fixed location data. So an example is in your business, you have the customer location where a customer is existing, and you know that come today, come tomorrow, a week after this customer, you will still get them at the same location, or a weather station, or an institution, or an office. Any coordinate or any geographical location you have that is not bound to change, and you want to analyze it, then you usually get that as a fixed location data. Then another one is the exhaustive data. So this is the one that now summarizes the above two examples, the event data and the event data and the fixed location data now into an area. So like you can aggregate an area based on the above two types of data. So for instance, maybe you want to understand the Maseno area in relation to the number of businesses that have been set up there. So you can aggregate and define that Maseno area as a Maseno market, factor to the customers that are existing in that area. So if you have such kind of a data that is summarized to an area, then that's an exhaustive data. So usually this data comes in when you are defining some densities like population density, road network density, then you are defining it within an area. For instance, you want to look at the population density within the counties in Kenya. So counties in Kenya serve as your area. Then now the population within that area, which are point location, if you come to think of them, there are people who are living, you get household and people who are within there. So if you summarize that into an area where an area here is the county, then you are dealing with an exhaustive data. So you find this one very common. For instance, this map we were looking at, we said this is basically a map showing population density within countries, and where it's dark, those are countries where they are highly populated, the population density is high. So finally, this is what we did last. We looked at where spatial analysis is applicable, and it said it's applicable when you have a combination of two main questions, a question that asks when and a question that asks where. So if you have in your data or in your analysis process, you have defined your objective and the questions, and they revolve around what has happened where. And then it goes a little bit further, and you are asking questions like things that are happening within a certain location. How does it affect the variables around that location? So if you have such questions, then spatial analysis is the way to go. So spatial analysis, we said it will always offer a new perspective of looking at things, which goes beyond just creating map. Basically, it helps you generalize an area and objects in location, and you can determine the relationships between these objects within a location, and also you can determine relationship between one object and the other within a map. So we had just begun here, and this is now where we are going to start today. So I want us to take a few minutes and now look at different use cases and examples of spatial analysis that you can conduct. So the first one here is called suitability analysis. Very interesting. Let me pose a scenario to you. So let's say you want to open a business, like that business that you've been dreaming to start, and you've been saying, if only I can get this amount, I would start doing this business. And we all know that business is greatly influenced by the location where you set a business. It's a great determinant of whether your business is going to be successful or not. Basically, whenever you are setting up a facility, even setting up a school and all that. So going back to our business example, then you have potential business sites that they can work well for you, and you know. So a good example would be, now among the locations that you are suggesting that you can set up your location, which would be the most favorable or the most suitable location for you to set up that business. So if you have such questions around your analysis where you are comparing different locations to determine which is the best location for doing something, then you are looking at analysis, a spatial analysis method. We call it suitability analysis. So as the name suggests, suitability helps you get the most suitable location. For instance, you are in a distribution business, then you want to identify, now amongst your markets, where would you set a distribution point, like a warehouse? For instance, think of a company like Coca-Cola, where they might be having a main facility where they manufacture their soda, then they package it in the they package it very well and put it in trucks. Then they want to spread their product and the commodities in the entire country. So it doesn't make sense for the trucks to keep on going back to the main plant, for them to refill, drop the empty crates there, pick other crates, and now distribute them in the market. So they have to get distribution points, like warehouses in the country that are strategic and can serve big areas. They can serve most of their customers. So this is the best use scenario of a suitability analysis. So basically what you do in suitability analysis, you define your area, like what you are looking here. So what you are looking here, you can see a point, then within a point, there is an area around it. Like where there is my cursor, you can see there is a blue point, then an area around it. So they've defined an area which is 15 minutes. For instance, this can be a distribution problem where you are saying that you can effectively meet people that are within 15 minutes of where your depot is. Then you place it, draw an area of 15 minutes around it. Then you have variables, non-spatial variables now within them. Now this could be, if it's a distribution problem, now here you are looking at how many of your actual customers are really there. Then you are looking at what is the value of the people that are within there, what's the population density, and you want this to define the most suitable area. So you can see these are like color coded, and I believe the meaning of this map is where now the color is bright red, that shows now the most suitable area. So you come up with something that is called a suitability score, and the suitability score now helps you judge which is the most suitable location to consider. So whenever it's a question around which is the most suitable, blah, 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 then that means it's a suitability analysis you are facing. Could be setting up a business, setting up a hospital, setting up something new like a distribution point, or when you want to buy a house in a safe residence. So you identify different areas, then do your analysis to determine which is the most secure. Another type of analysis, very useful, it's hotspot analysis. Now, the hotspot analysis uses the logic of hot and cold. Basically, this one helps you cluster spatial phenomena. Then you can get an overview of where they are dense and where they are sparse. So, for instance, let's say you are looking at a disease infection rate, like COVID infection rate. And so you have reported cases that can be pinged to a certain area. Then you want to understand which are the red zones. I know you've been hearing this, which are the red zones. So hotspot analysis is the way to go. So you can summarize and cluster this information within an area, like what you are seeing on this heat map. Then this heat map helps you identify which are the red zone, so the red zone usually represent the areas that the variable of study is high. For instance, it can be the rate of infection, as we've said, or it can be something like criminology, a crime rate, or it can be something like road accessibility, which is a good variable. Doesn't just have to be a bad variable, or it can be just a concentration of the customers if it's in a business setup. So if you do such a hotspot analysis, it gives you a good view of where a variable is concentrated, or of where a certain statistical phenomena is happening mostly. Another one, very common, I know this one you've had or you've also interacted with this, is called network analysis. So network analysis, it's basically answers questions like which is the shortest route, or which is the most optimum route for me to do the following. So when you are talking about spatial analysis, now this is like when you have a task that, network analysis is when you have to like accomplish a set of tasks. Then these tasks, they have a certain order they should follow. And now you are looking at the most optimum way of achieving such a task. A task can be something like you are distributing, let's say you are in our very famous example, you are doing a distribution for Coke, and then they want to see how can they optimally stop at the customers to drop the crates of soda and pick empty crates and have the most optimum and effective route that will save them cost and save them time. So such an analysis, they are best performed spatially using this method we call network analysis. Or when you are asking your Google map, show me the best way to get from maybe Nyawita, then you want to get to Luanda Market. So you are there, you want to go with a bike, so you ask Google Map, which is the best route. So at the back of it, it does the network analysis, looks at variables like traffic, the most favorite routes for many people, it looks for such thing. Then it returns to you an output of the most optimum or the best route, and it computes for you how long it will take, things like that. So behind it is a network analysis, very interesting analysis. Lastly, so this is an example of spatial analysis, network analysis. Lastly is spatial clustering. Just like the normal clustering where you have clusters, you have objects you have objects, you remember just a typical scatter plot, as where you have points and each point they show interrelation between two variables, something like that. So you can, then you are looking if there is a relationship in these variables, or if they can be categorized in a way that you can understand them into groups. So just the normal application of clustering. So you can do a spatial clustering where now basically you are clustering map points. So for instance, look at the map before clustering. This can be, let's say this can be something like customer locations, or okay, let's say these are households within an area. Then so you want to understand, maybe you want to target specific households, areas where there are households that are close to each other, and maybe you are setting a business, you want a business that is close to potential buyers, and now your potential buyers are these households. So you can see before household, you don't understand any pattern, but if you run a spatial analysis component that we call, this is jumping to the next slide, wants us to finish very fast. So if you run now the spatial clustering, so you can see the transformation, how it looks. And maybe the rule that you set here is give me groups of people that are not less than 100, that is called a component that we call proximity, people that are close together. Okay, I don't want to get into much details of how proximity is computed, but ideally you have an output like this. So basically now, if you look at this, you can start identifying, now these are the areas that have high density and high density of your variable. Our variable here was the number of households. So you start seeing well-colored densities of where you have most of the households there. Now, lastly, so where can you start working with spatial analysis? Where can you start? So basically, as I told you in my first example, spatial analysis, for me, I began with the business intelligence tool. Most of them, they are free and available, and they have map components. So if you are working with something like Power BI or something like Tableau, they have that component of spatial analysis. And if you have any data that is locational, you can start creating maps there. But basically, you can group the platforms into three. Like you can have Python. Python has the main package called GeoPandas. And for those who have interacted with Python, the first package you interact with for data manipulation is Pandas. So GeoPandas works the same as Pandas, and it will help you manipulate data. That's like okay, for me, that's the one that I would recommend. And the learning curve there is not as steep, so you can start learning that like automatic. Then other tools like database tools like SQL, Postgres, and PostGIS. These ones also, they have the spatial component. Actually, a tool like SQL, it also has a very powerful spatial analysis component that you can integrate and use them. So then R also is not left behind. R has a package like RGeos. Then I love this one, GPplot. So with these packages that I have outlined here, I will share this presentation with you. Then, so with these packages, you can start working with spatial analysis. Then you can see what the other packages I mentioned. A package like QGIS, highly recommended here. It's open source, it's free. Then it has so much capabilities. You can start interacting with that. But all this, it all starts with interest. And I think spatial analysis is one of the ways that you can enrich your analytical tools to sell yourself out as a strong data analyst or as a strong data scientist. It is a way to help you be conversant with both structured and unstructured, and now spatial and non-spatial data. Thank you, guys. So back to you. If you have any question for the time remaining.
so much, David Muturi. That's been a very, very nice illuminating presentation. We have
Thank you.
4 minutes for if you have a question, you can put it on the chat. But my quick question will be, when you're talking of the spatial analysis,
Yes.
certain qualification within the university, like must you have reached third year for you to be able to do this analysis, or do you think this is something that even a second year can be able to learn and apply?
Wow, very nice question. So I will answer that with my experience. So in my study, maybe I was not very keen in class, but I didn't get much exposure into what spatial analysis was. I didn't get much exposure to this side of spatial statistics. But when I went into the field, had a challenge that needed application in terms of spatial analysis methodology, I learned very fast. So what that means is that as long as you have that passion for data and you know a few tricks of working around with any data, you are good to start, and you are good to rock in spatial analysis. So yes, this is a field that any person, whether first year, second year, third year, fourth year, or somebody out there, you can learn and start incorporating this one in your analytics pipeline.
A quick question, Ben Cole. What is the quickest tool or way to get coordinates or geometry data locally, since one of the most vital data when doing spatial analysis? There is also another one by Captain Caleb who asks, where exactly can we apply spatial analysis? I would want to respond to that one and ask Captain. It will be nice if you go a bit later on through this video, because he's really mentioned a bit of several areas. And then I'll ask you, David, if you don't mind, to respond to Ben Cole's question.
Okay, thank you. So Ben, you are asking, like, which is the quickest tool that you can use to get coordinate or geometry data? I think I will, as I'm sharing the summary, I will share a few sites that you can get free spatial data. So wherever you get, in most cases, wherever you get non-spatial data, that is usually spatial data, like tools, places like Cargo, you get data with geometry there. But so you are asking the quickest place that the quickest tool. So I would recommend start with the survey tools. So with the survey tools like ODK, they are easy to create. So you can create your sample surveys there, collect geometries in area like Maseno, an area that you are conversant with, then load this in packages like R, Python, QGIS, and you are good to start your spatial analysis. Yeah.
We have less than a minute. I want to thank you so much, David. Okay, Captain Caleb has asked whether we must learn either Python or R before commencing to spatial analysis. Maybe you can do that in like 3 words, because we don't know how long we have, but it's less than a minute.
It would be good. It would be good to have these skills in your pocket, but the answer is it's not a must, but it will do you good to have them, to have the skills of Python and R. Yeah.
So thank you, everyone. I'm going to upload this thing tomorrow on YouTube, and I will share on my status. Please remember the bootcamp that is coming. I will also put there, and I think in the YouTube, I will also share the slides and any other link that David Muturi will share with us.